So we're doing linear graphs. So linear means it's a straight line. So what we're going to see, it's when we're going to see our, we're going to have a set of axes, so like the y and the x, which you're all used to, and you're going to see like the line will be straight in some way. Okay, so when we have a straight line like that, it'll have a formula. So this line will have a formula. So we're going to change it to be a plus bx. So we'll see that later. And so when we have a formula, and you can see here in our example here, we've got a little formula or equation there. When you only have, see how x is just x, it's not x squared or x cubed. So when you just see a y equals and something x, that's how you know it's a straight line. So we won't use anything but a straight line. So we'll see it like that. So that's the rule for the straight line. So what we're going to do first is we're going to practice drawing that equation on a graph. So one way you can do it is you can set up a table of values. So say, for example, what we're going to do is we're just going to pick, just pick numbers for our x that our x could be. So I'm just going to go 0, 1, 2, 3, 4. They may tell you which ones to do. They might say set up a table of values, but I'm just going to use those 4 values. So what we're going to do is we're going to find the y value using that rule. So the rule says to do 4 minus 2x. So in that first example, it would be 4 minus 2 times 0 because x is 0. So you end up with 4. So that's how you know that's 4. And then you just keep applying the rule along as you go along. So the next one would be 4 minus 2 times 1. So that's going to be 2. This one will be 0. This one will be negative 2. And just to show you, I'll do the last one. So you've got another example. So the rule was 4 minus 2x. So in this case, x was 4. So it would be 4 minus 8. Which is why I got negative, you'll get negative 4. Okay? So there's a table of values. So we've set up a table of values. And now we could plot those points. So if you have a look, that is a point on the graph. Yeah? So that we've got like 5 points there. So you could plot them. So when x is 0, so you go along the x, y is 4. So there's 1 point. When x is 1, y is 2. When x is 2, y is 0. When x is 3, and so on. Okay? So then once you've done that, you can get your ruler and you can join your dots up and you draw a line like that. Okay, when you sketch a straight line graph, you actually don't have to draw every point in it. So we might just say that. So we might write a little note when sketching a straight line graph. We just need 2 points really, because it doesn't matter which 2 points. The line will go through them all. So when sketching a graph, you just need to need 2 points. So if you were given the equation and asked to sketch it, just use 2 x values. And you can use easy ones. Use 0, use 1, because it's easy to put that into the formula. So, here I just picked that one and that one. And if I plotted them, the line would go this right way, correcting. Okay? All right, so here on this page, we've got the calculator instructions on how we could get the graph of a straight line on our calculator. So I'm going to pause it here and we're going to go onto the calculator and I'll show you. But this is the equation we're going to look at. Okay, so just to recap, you might want to write that the fx1 is the same as writing y equals, yeah? Okay, so you don't need to write the y equals part. You just had to write the 8 minus 2x, okay? So just pop that in. All right, so what we're going to look at now is the slope of the straight line. So the slope, another word for the slope, might be also the gradient. Okay, it's also like the steepness, that's what the slope is. Or you might even, sometimes they use the word rate. So if something's going up, so say this was, you know, a value of an investment and you've got a straight line, so the rate it's going up, that's the gradient. All right, or the slope. Now just also, okay, so we're going to look, so we're looking at the slope, but what I want you to get used to, for us, that's going to be, we're going to write the slope is going to be called the B value for us now. So we used to previously know it as the M value. So you might want to write that in brackets, like previously known to you guys as M. But we're going to use the letter B. Okay, so when we see these formulas, we could find the letter B, the slope, by using this formula. Now you can use rise over run, or what we can do is we can use 2 points. And this formula up here where you've got y2 minus y1 and x2 minus x1, that's when you're using the 2 points. And that's probably the one that we're going to use the most, because if they said what's the gradient of this line, best just to go find 2 points that the line's going through, and we'll look at it. So we'll have some examples in a minute of doing that. But what we do need to know is when we have a positive slope, so you can see when the line's going up, that means we'll see the B value. So you might write that. The B value will equal a positive number. Okay, so you might, for an example for this line, it could be y equals, 2x plus 4. So you can see this letter number here is the B, so it's a positive letter. Okay, when you've got the slope going downwards, negative slope, so that means the B value equals a negative number. So for an example, we could say y equals negative 3x, plus 4. So you can see this B value here was a negative number. Okay, if you have a zero gradient, you've got this horizontal line. So you might write that because, it says it there. It's a horizontal line. And an example of that, so there's zero gradient. So an example of an equation with that, it'll simply just be like y equals 4. Like there's no x in there, all right, because there's no gradient. It's just a flat line. If you have a vertical line, so that's what, like here, the slope is not defined. So, and what the equation will look like for that one, an equation, it might be like x equals 3. So say that would be 3 there on the x-axis. And up here, when I did my little example, that would be 4. All right, so just so we're aware. Now, you just want to be mainly aware of a positive and a negative. So when you look at that graph and you're trying to work out the equation, you can see it's going up. That B value, when you're working it out, it should be a positive. It shouldn't be a negative, so that you know that you're doing it right. So let's have a go here. So here it says find the slope of each of the lines. So what we're going to do is we're going to write B, so we're getting used to it, the slope. Then I'm going to write the formula that was on the other page, which was this, y2 minus y1 over x2 minus x1. So you just need 2 points when you're trying to find the gradient, 2 points that the line is going through. So I'm going to call this point down here point 1. So that means it's called x1 and y1. And I'll call this other one would be my point 2. So it'll get called x2 and y2. So then when we pop that into our equation, you just substitute what they are. So y2 was 9 minus y1, which was 3, over x2 was 5 minus x1, which was 2. So we end up with 6 over 3, which equals 2. Now, the graph is a positive graph, isn't it? So if we look at this, yeah, we might say this is a positive slope. And we can see our answer is a positive number. So that's good. Okay. So then when we're looking at, the next one, it's a negative slope. So we should see a negative answer when we work it out. So let's have a look at that. So we need to write, we're finding the slope. So I'm just writing B for the slope. So you're used to it. I'm writing out the formula. Really important, you're writing your formulas out. You cannot get consequential marks in a test if you don't show me what you're doing. So when often people just write the answer, if you're wrong, you're wrong. You don't get any of the points if it, say, it was a 2-marker. If you had put your formulas but somehow something's wrong, you may get one if you're picking the right thing. So make sure you're doing that. So I'm going to call this one x1, y1, and this one x2, y2. It doesn't matter which one you call point 1 and which one you call point 2. You would get the same answer if you did it vice versa. So let's do this one. This one would be 4 minus 7 over 5 minus 2. So we end up with negative 3 on 3, which equals negative 1. So we see that is a negative number, which is what we wanted because it was we could see it was a negative slope. Okay, so here's some examples. So here it says find the slope. So that's the B value. Let's just write that there so we remember. And the line that goes through these points. So all we can do is say that's point 1. So we'll call it x1, y1, and we'll call this x2, y2. And we know that the slope formula is this. And then we're just going to substitute that in. So it is 9 minus 6 over 3 minus 2. So we end up with 3 over 1. So the B value or the slope is 3, or the gradient, whichever one you want to call it. And then this one, I'm just to show you, it won't matter. I'll call this one x2, y2, this one x1, y1. If you did it the other way, you'll get the same answer. So let's have a look. So we know that the slope formula is y2 minus y1 over x2 minus x1. So if I go with what I said the first point was 4 minus 2 over 1 minus 5. So I end up with 2 over negative 4, which would simplify to negative 1/2. Now, just to show you, to prove, if I called it the other way round, and I'm going to do it the other way round to show you, we'll still get the same answer. So we would have, in this instance, we'd have 2 minus 4 over 5 minus 1. So you end up with negative 2 over 4, which is still negative 1/2. Okay? So that's just showing you, it doesn't matter which one you call point 1 or which one you call point 2. You just need 2 points. All right, so you're going to do exercise 5D. So I'll pop it on our class page in a minute.